Today we're going to do a couple review questions from section P.6, getting ready for our test coming up. Our first question is asking us to add two algebraic fractions. In order to do this, we need common denominators, so our first step would be to factor any denominators that aren't already factored. So I'm going to start with this trinomial. We need to factor x squared minus 12x plus 32. We need two numbers that multiply to be 32 and add up to negative 12. So I'm going to use negative 8 and negative 4. Then when I try to get a common denominator, I need to look at my second fraction, and I notice that it is missing the x minus 4 factor that the first fraction has. So I'm going to need to multiply both numerator and denominator by x minus 4. I then have to simplify all of this numerator stuff before I can do any reducing. So I'm going to have x squared plus x minus 3 plus, I get 3x squared minus 12x when I distribute. It is now all over my common denominator of x minus 8 and x minus 4. Combining like terms, we have an x squared plus a 3x squared, so we get 4x squareds. We have an x and a negative 12x, so negative 11x. And our only constant is that negative 3. And then we keep our common denominator. You would want to try to factor the numerator, but it does not factor. Second one, notice we are subtracting. Our first step again is to get everything factored so that we can see what we need for a common denominator. So we would factor this into x plus 4 times x plus 4. And our second fraction factors into x plus 4 and x minus 4. Our common denominator then needs 2 of our x plus 4s, since our first fraction has 2 of them. And it also needs this x minus 4 piece that we have right here in our second fraction. Okay, so looking at what we're missing. Our first fraction is missing the x minus 4. And our second fraction is missing that second x plus 4. All right, foiling right here, we need to take x minus 4 times 2x plus 1. We would get 2x squared. We get a negative 8x and a positive x, so negative 7x. And a negative 4. In the second part, we are distributing. We would get 3x plus 12. But remember, we are subtracting, so we're subtracting 3x, and we are subtracting a 12. Again, combining like terms, we would have 2x squared minus 10x minus 16. All over our common denominator. I'm going to simplify that a little bit. X plus 4 times x plus 4 is just x plus 4 squared. All right, for question 3, we have some complex fractions here. Best option is to look at all of the little mini denominators in their factored form. So I'm going to change this x squared minus 9, and I'm going to think of it as x plus 3 and x minus 3. And now when I look at all of my little denominators, my common denominator would need an x plus 3 and an x minus 3. So I'm going to multiply both the numerator and the denominator by those two factors. You can put a 1 under it if it helps you. All right, distributing to our first fraction here. Both the x plus 3 and the x minus 3 would drop out. We're left with just the 4. Distributing to our second fraction, our x minus 3 would drop out. We are left with a 2 times the x plus 3. On the bottom half of our complex fraction, multiplying to our first fraction, the x plus 3's would drop out. We have a 1 that's getting multiplied to an x minus 3. Multiplying to our second one, the x minus 3's drop out, and we have a 1 times an x plus 3. Simplifying all of the numerator, we have 4 plus 2x plus 6. The denominator, multiplying by these 1's, doesn't do anything. We have x minus 3 plus x plus 3. Simplifying that, we have a 2x plus 10 all over a 2x. Now we can divide a 2 out of everything. I can factor a 2 out of the numerator and then reduce that with the 2 in the denominator. So I end up with a final answer of x plus 5 divided by x. Now we should look at domain restrictions quickly. If we go back to our initial question, we look at our denominators. X cannot be a negative 3, x can't be a positive 3, and that works for the top denominators as well. All right, so we have to restrict that x cannot equal positive and negative 3. Then we have to look at our final answer here and notice that our denominator is an x, and x can't be 0. We can't divide by 0. All right, our fourth example, another complex fraction. If we use the same method that we had before, we would need to see everything in its factored form. So I would have to factor this 2x squared minus 2. I could take a 2 out. It then factors into 2 times x plus 1 and x minus 1. This denominator would factor into x minus 3 and x plus 1. So looking for all of my common denominator pieces, I would need to have a 2. I would need an x plus 1. I would need an x minus 1. Looking at this denominator, I already have the x plus 1 listed. Looking at this denominator, I have the x plus 1, but I don't have the x minus 3. So that's going to need to be my common denominator. Okay? So I would have to multiply all of these fractions by that piece. Okay? So lots of little pieces. We need a 2, an x plus 1, an x minus 1, and an x minus 3. All right, so let's see what we have left. For the top half of our complex fraction, we had a 2, an x plus 1, and an x minus 1 in our denominator here. So that would reduce out those first 3 pieces. So we really just have the x minus 3 times a 1. For the denominator of our complex fraction, the bottom half, in our first piece, we have a 2 here. The x plus 1's would drop out, but we have another 2, an x minus 1, and an x minus 3 that's all still in there. Plus, when we distribute all of those pieces to the second one, we have our x. The x minus 3 and the x plus 1 would drop out. We'd still have the 2 and the x minus 1. So we have a lot of cleaning up to do here. So our numerator is x minus 3. Our denominator, we have a 4 getting multiplied to this. I'm going to go ahead and FOIL that out. We've got x squared minus 4x plus 3. On the second one here, we've got a 2x getting multiplied to an x minus 1. Okay, let's clean that up a little more. We are going to have, if we distribute, we would have a 4x squared minus 16x plus 12. Multiplying the 2x into that second part, we get 2x squared minus 2x. And then we have some like terms we can combine. So we're going to end up with 6x squared minus 18x plus 12. Now, we could factor that a little bit. We could take a 6 out of everything. We'd have x squared minus 3x plus 2. That can be factored again into x minus 2, x minus 1. Nothing will cancel out, but it does allow us to list our domain restrictions. So from here, x can't be a 2 or a 1. Going back to all of our little denominators from our initial question, we can't have a negative 1 or a positive 1. We've already taken care of the negative 1. We also can't have a 3 from that. So our answer would be x minus 3 divided by the quantities 6 times x minus 2 times x minus 1. And our restrictions are x cannot be 2, 1, negative 1, and 3.